This is grade 12 University Physics, Unit 1 Dynamics, Lesson 8 Relative Velocities. Question: a helicopter travels with an airspeed of 55 meters per second. The helicopter heads in the direction of west 35 degrees north. What is its velocity relative to the ground if the wind velocity is 21 meters per second east? So let's start by drawing this on an XY plane. First, we have the airspeed, which is 55 meters per second, west 35 degrees north. But the helicopter isn't going to be traveling in this direction from the ground's point of view, because there's a wind velocity pushing it to the east at 21 meters per second. Now when we take the vector sum of its airspeed and the wind speed, we get the velocity of the helicopter relative to the ground, which looks like this. Now we can solve this triangle using cosine law and sine law, but we're going to leave that to the calculus and vectors class. In physics, we're going to use components to solve this problem. So let's start by splitting up the airspeed into its x and y components. Now since we know the angle and the magnitude of the airspeed, we can calculate the x and y components using simple trig ratios, as follows. Now the wind speed we don't have to break up into components because it's already completely along x. It has no y component at all. And when we add these two vectors, we will get the velocity of the helicopter relative to the ground. But we need to add the x component and the y component separately first. Now when we look at the x component, we have 45.1 meters per second, and that is to the west. And then we have 21 meters per second to the east. We can rewrite this as 45.1 meters per second west minus 21 meters per second west, because east is the same as negative west. And then we finally get our x component as 24.1 meters per second west. Now the y component of the airspeed we solved to get 31.5 meters per second north. Now the wind speed has no y component, so our final y component is simply 31.5 meters per second north. Now if we add this vector sum for the x component and the y component, we will perfectly get the magnitude and direction of the velocity of the helicopter relative to the ground. But we still need to solve this triangle to figure out what that direction is. Now this triangle is a little bit different from what we started with. We started with a triangle where we would have to use sine and cosine laws. But in this final triangle, because we have a right angle between the x and y components, we can simply use tangent to find the angle and Pythagorean theorem to find the magnitude. And when we do that, we solve for the final velocity of the helicopter relative to the ground as 40 meters per second west 53 degrees north.